So last time we learned about the three basic trig graphs, and what we're going to do is we're going to learn about the three reciprocal trig graphs today, so cosecant, secant, and cotangent. So what we're going to do is we're actually going to graph the original trig functions first. So let's start off with y equals sine x. I'm doing it in green because I'm going to superimpose cosecant on it in a second, and then we'll see how we can kind of think of this in an easy way. If you remember, sine had this behavior. It started out at 0, its maximum was 1, and its minimum was -1. One period of sine ended at 2 pi. Halfway between was pi, and then pi over 2 was a quarter, and then 3 pi over 2 was the other quarter. So hopefully you remember the reason why sine behaves this way. It comes from the unit circle, right? When we look at from the y coordinate perspective, we go from 0, 1/2, rad 2 over 2, rad 3 over 2, and 1. We have this increasing motion here. We have this increasing motion from 0 to pi over 2, which is exactly what we see from 0 to pi over 2 on sine of x. Well, anyway, I'm not going to go over and review the whole thing again. We're going to look at this in terms of cosecant. So cosecant, let me switch that back there. If we look at y equals cosecant of x, well, cosecant is really 1 over sine of x, right? So what we can do is we can literally take all of our sine values on the unit circle and flip them upside down because cosecant is reciprocal of sine. So rather than being 1/2 at pi over 6, pi over 6 really now equals 2 over 1. At pi over 4, rather than being rad 2 over 2, we really have 2 over rad 2 because we're looking at cosecant. And then same thing for pi over 3, it really becomes 2 over rad 3. And then 1 over 1 is really just 1, so that doesn't really change that much. What really changes here is at 0 pi radians. 0 flipped upside down. 0 over 0 is not 0, it's actually undefined. All right, so that means that just like tangent in the last video, we're going to have an asymptote here, which means I'll circle that in red. Okay, so let's just go ahead and draw the asymptote. When I get ready to superimpose this, I'll go ahead and draw the asymptote on 0 because that's where cosecant is undefined. In a calculator, I've checked out all of these values here. So, well, 2 over 1, that's really just 2. That's a piece of cake. 2 divided by rad 2 is about 1.41. And then 2 over rad 3 is 1.15-ish. And then we get down to 1. So what we have here, from 0 all the way to pi over 2, what we have is we have this decreasing motion right here. It starts off at 2, slowly gets down to 1. And so the way that manifests itself in terms of the graph is that from the undefined, this infinitely large number, right? Because all of these numbers here, all those numbers that I just colored in red, all those numbers are greater than 2, right? Because it's slowly decreasing as it approaches pi over 6, which outputs a value of 2. That's our first known value. So if all of those numbers are greater than 2, then we can draw the graph and make it look like this. And as it approaches pi over 2, cosecant becomes 1. Right? And we can draw an arrow there because it increases without bound as x approaches 0 from the right. Well, let's take a look at the unit circle again at our next critical point, and I'll just identify the next critical point as pi. And the reason why I identify the next critical point as pi is because that is where the next asymptote is going to occur because we're going to flip 0 one more time. So at pi, I end up with another asymptote. And let's take a look at the values in between. So from 1, we're looking at 2 over rad 3, which we see here as 1.15. We see rad 2 over 2, or in this case 2 over rad 2 because we're dealing in cosecant, which is 1.41. And then 1/2 becomes 2. So what we see here is as we go from pi over 2 down to pi, we have an increasing motion. The numbers are getting larger as we move down to the next undefined section. So how that looks is things are increasing without bound as we approach the next undefined section. Now, I'm going to go ahead and speed through the next section here. The next point that I'm going to be concerned with is 2 pi, because at 2 pi I'm back to sine equals 0, which is undefined for cosecant, which means there's another asymptote here. The reason why I'm going to speed through this next section is because notice how sine has this symmetry to it, where if I fold it over and then fold it downward, I'll end up with the same thing. Well, I hope you can kind of make this connection that between pi and 2 pi, that motion is going to happen. All right? Now, another way you can think about this is because cosecant is sine upside down, or sine reciprocal, you can see the graph as basically being sine upside down, but with a little bit of a twist. The twist comes in where the asymptotes are. The asymptotes occur where the original sine graph touches the x-axis, right? Because that is where sine equals 0, and when you flip 0, you end up with something undefined. Remember, you can't divide by 0. I'll start calling you Scott. That's not a good thing. So, using this knowledge, hopefully we can graph cosecant really quickly. So if I say y, whoops, let's turn back to green to graph cosine. Y equals cosine of x. Well, remember, cosine of x looked like this. Right, and we got 2 pi here, pi, and pi over 2, and then 3 pi over 2. Okay, let's go ahead and draw in our values here. Okay, so let's take the same rules as sine. Where are the asymptotes going to occur? Well, asymptotes are going to occur where the original cosine graph, the green, hits the x-axis. So that's right here, and that's right here. So we are going to have asymptotes at pi over 2 and at 3 pi over 2. If we are going to graph y equals secant of x, remember, secant is really 1 over cosine of x. So everything is just upside down at this point. So from here, from 0 to pi over 2 in cosine, we arced down. From 0 to pi over 2 in secant, we're going to arc up. From pi over 2 to 3 pi over 2, we have this almost parabolic motion, this u. And since secant is 1 over cosine, this is now upside down. And then from 3 pi over 2 to 2 pi, I like to look at it backwards actually. From 2 pi backwards into 3 pi over 2, we have this downward arcing motion, which means now we're going to have an upward arcing motion. Now typically I try to get people to graph cosine and sine first before they graph their reciprocals. It just helps visualize it a little better. Let's take a look at cotangent, because cotangent is a little bit different. It does follow the same principles, except the asymptotes are going to shift position a little bit. Okay, so let's take a look at the original tangent function. Okay, at pi over 2, at pi, 3 pi over 2, and at 2 pi. Okay, so if you remember anything from tangent, tangent had asymptotes occurring at pi over 2 and 3 pi over 2, and it looked like this, like a cubic function. Okay, or this is 0, 1, and -1. Okay, so tangent versus cotangent. Let's take a look. Let me delete some of this garbage down here. Cotangent you have to be a little more careful with, and I'm not going to superimpose that because it's going to look really messy. What you have to understand is that all the rules apply. Cotangent is still tangent upside down. So what you're going to see is you're going to see now this piece on bottom, this thing upside down, and then this thing on top. But there's a twist. There's a change in the asymptotes. Cotangent is really 1 over tangent. And because tangent is really sine over cosine, cotangent is really cosine over sine. What that means is x coordinate divided by y coordinate. So let's take a look at where the asymptotes are going to occur this time. Let me go ahead and upload a new unit circle here. That way we get something a little more clean. Okay. Well, the only place an undefined section can occur is at 0, pi over 2, pi, 3 pi over 2, or 2 pi. Well, in the original tangent function, it's always y over x. So here it's 0 divided by 1. Well, that's 0. That's a piece of cake. But remember, we're dealing in cotangent now, which is 1 divided by 0, which means here I have an undefined section. So at 0 and 2 pi, I have something undefined. So at 0, I have something undefined. See, pi over 2, pi, 3 pi over 2, 2 pi. I have another undefined section at 2 pi. Well, here at pi over 2, remember it's x divided by y, so it's going to be 0 divided by 1, no problem there. At pi, I have negative 1 divided by 0. I have an asymptote at pi. So let's draw an asymptote there. And then at 3 pi over 2, I'm safe. Okay, now all there's left is to flip tangent upside down. Now again, because the asymptotes have shifted, the graph shifts as well. It's not going to be from 0, there's this arcing down motion like I said before. It's not going to occur like this. That would be wrong. Because for that to happen, we would have to cross the vertical asymptote, and you can't do that. So from pi over 2, it is going to arc down. And then from 0 to pi over 2, it's going to have this upward motion infinitely without bound. And then at 3 pi over 2, it's going to repeat itself. And that is your graph of cotangent. All right, so hopefully that's not too confusing. We'll do some graphical changes in the next video. See ya.